Everyone, welcome to this video presentation. I'm Jamaloddin Jamali from Mechanical Engineering Department, American University of the Middle East, Kuwait. The title of this work is Mode 1 Fracture Testing of Polyester Polymers. This is the work that I did with the help of my students Ahmad Ashknani, Al-Kanderi, and Fajer Hussain. As you know, polymers are constituents of polymer matrix composites or PMCs. PMCs are being widely used in different industries. This is mainly due to their high strength to weight ratio and high stiffness to weight ratio in comparison with metals. This is, however, when we compare here the resistance against fracture for PMCs is termed as fracture toughness. We notice that they lack the toughness of metals. Obviously, polymers, as you see over here also, they have a very low value of toughness. Toughness is the amount of energy absorbed in a material before fracture. In order to study enhance the toughness of polymer composites, in this work we start by looking at fracture behavior of polymers that are used in the manufacturing of PMCs. So the characterization of a common polymer system subjected to mode 1 and later mode 2 and mixed mode loading is a first step on the path to a predictive model for the mixed mode fracture of polymer composite systems. The material we study here is unsaturated polyester manufactured by United Oil Project Company in Kuwait. Unsaturated polyesters are thermosetting resins. They are used in the liquid state as casting material in sheet molding compounds, as fiberglass laminated resin, as a thermoset polymer matrix in prepregs and other applications. To study this material, we follow this process. The mode 1 fixture is designed and manufactured. The tensile testing specimens are made using silicone molds matching with a STEM standard. The specimens are then tested under tensile testing to measure their mechanical properties to be used later for the calculation of fracture properties. To study fracture response of these materials, fracture testing of polyester is performed using the data and concepts from fracture mechanics, plus the fracture mechanics failure model. We aim to predict fracture properties of the composite made of this polymer. In order to study mode 1 fracture properties of polyester, two test devices have been introduced in the literature: compact tension CT and single edge notch beam or SENB testing. For CT, we used the same concept. However, we proposed different designs as you see over here. And then considering simple design to manufacture, ease of inserting the fixture in the UTM grip, we chose this design to be fabricated as CT fixture. Over here you see the drawing of the CT fixture. Dimensions are assigned to make sure that they fit properly in our universal testing machine that will be introduced in the next coming slides. Over here you see this is what has been manufactured and used in our lab. There was a minor modification to fit the part properly in the UTM grip, and this is the whole CT parts used in the CT testing, while the specimen is fit into the upper and lower yoke of the CT fixture. In order to study the mode 1 fracture properties of polymers, single-edge notch beam has been introduced in the literature. We've worked on three different detailed design in SolidWorks based on the literature as shown over here, taking the ease to manufacture and of course cost as a result into consideration, as well as ease of inserting the fixture in the UTM grid. We chose this design to be manufactured as SENB fixture for our testing. This is what is manufactured and used in our lab. You see over here, the loading nose applies load, and we have these supports to apply 3-point bending. The material that is used for this SENB fixture is A36. On the left side, you see the setup for SENB testing. As in the process of studying fracture properties of the polymer, we need to know tensile properties of the material. The next step is preparing polyester tensile testing specimen. Over here, we use silicone mold that has cavities the same size and shape of the tensile testing specimen based on ASTM B638. The silicone mold itself is made by the help of wooden mold. The mixing ratio for hardener to the resin is 1.5% for the polyester that we use. During the mixing process, we make sure that no bubble is introduced to the specimen. After curing, we use the specimen for the tensile testing as shown in the right-hand side picture. The tensile testing machine that is used for fracture testing as well is Tinius Olsen tensile testing machine model 50SD. This machine has the load capacity of 50 kilonewton, and the displacement is measured by the displacement sensor or extensometer. The engineering stress versus engineering strain curve calculated by the help of this tensile testing machine is shown over here for different tensile testing specimen. As you see, a consistent response and certain plastic deformation. The displacement rate for the tensile testing was 5 millimeter per minute. As a result, we have the following numbers calculated for the polyester specimen. Maximum stress is 90 megapascal, fracture strain is about 9.5%, stiffness is 1.39 gigapascal, and the average tensile strength is 19 megapascal. Bear in mind that some of these values, like E, will later be used in order to calculate the value of the strain energy released. For mode 1, this is denoted by G1 or G1C. The next step is preparing specimen for SENB and CT test. Resin and hardener are mixed, similar to the tensile testing specimens. The specimens are poured and cured in silicone molds. And the silicone molds were made by the help of wooden model and acrylic models. The holes were finished by drilling, and the last pictures are showing the SENB and CT specimen under fracture testing. To have a sharper notch for the crack propagation, we made a sharp cut with a depth of 1 millimeter by the help of cutter. To ensure that no heat is induced to the crack area during the cutting by the razor blade, the cutting was done hours before the fracture testing. This video is showing the process of single edge notch bending testing. As you see, a fast fracture happening during this test. And this is compact tension testing. We have added a label to observe the crack propagation. And again, you see a fast crack propagation and fracture. The result of SENB test, force versus cross-head displacement for different thicknesses of polyester specimens, are shown over here. Using the value of force and dimension, as well as the geometry factor f of A over W, we can determine the value of fracture toughness using equation 1. The geometry function is shown over here in equation 2. To ensure a state of plane strain, to measure the correct value for the mode 1 fracture toughness of polyester, fracture testing at different thicknesses are performed, and as you see, fracture toughness versus thickness for SENB specimens are shown. On the right, you see the values of fracture toughness average values with a standard deviation, which shows a minimal thickness of 15 mm is required to ensure the state of plane strain. For the CT test, we use the same thickness that was recommended from thickness study curve from the previous slide. And as you see over here, the value of load to start crack propagation in the specimen. Using these values, we can determine the value of fracture toughness for the CT specimen. In this slide, you see the comparison between fracture toughness values measured using SENB test and CT test. As you see, SENB gives an average value of 32.6 megapascals square root of millimeter for the fracture toughness, while the average value of mode 1 fracture toughness for CT specimen is 39.57. Taking the standard deviation of both tests into consideration, you will see very close values for the fracture toughness. However, there is a difference of almost 22% between the average values of fracture toughness using these methods. Mode 1 fracture toughness can be obtained through the formula shown in this slide, which result in the values of 0.74 for SENB and 1.1 for CT specimen. On the left side, you see the fracture morphology of a SENB specimen. In summary, in this work, we studied the mode 1 fracture properties of unsaturated polyester. This was performed using SENB and CT testing. The fixtures were first simulated and then manufactured. The values of maximum force resulting in crack opening were measured. Mode 1 components of fracture toughness and strain energy release rates were calculated using these two methods. There was a 22% drop in the value of fracture toughness measured by SENB compared to the CT test specimens. This could be due to factors such as out-of-plane load in the CT test. However, if we take the standard deviation of the result, we see very close values obtained from both tests. Thank you for watching this presentation.